last class, we saw that given any two lines L and M, a line P which cuts these two angles in two distinct points is called a transversal, and it makes 8 angles. We name the angles with numbers. In this class, we will study a special case where L and M are parallel. Now this is true for any two lines, but a special case is when L and M are parallel. When L and M are parallel, what happens is that we can prove that the corresponding angles are equal, the alternate interior angles are equal, and the interior angles on the same side of the transversal is supplementary. So then what? What if some of the angles are equal and what if some of them are supplementary? How we use that is, you don't have to break your head over wondering what is the measure of all the 8 angles. All you have to do is know the measure of any one angle. For example, randomly, let us pick 1. If 1 is 110, that is all you need to know. With that information, you can find out what the other 8 angles are. You will find out that out of these 8 angles, 4 of them will be 110 and the other 4 will be the supplement of 110, which is 70. So even though there are 8 angles, it is just these two. In 4 places 110 will come, and in 4 places 70 will come. Which will come where and why, that is what we will see now. Now, first we will prove that all these pairs are equal. The vertically opposite angles, the corresponding angles, and the alternate interior angles. And please note that the special case that for the parallel lines, it is only for corresponding angles and alternate interior angles. This will be true for all sorts of lines. I am just writing it here because we are going to use this information to prove the other two. So I am just writing it here, but it is true for all sorts of lines. It does not have to be just for parallel lines. Now let us prove the vertically opposite angles are equal. Suppose we take two lines. One is AB and the other is CD. Suppose it meets in a point O. Then what do we have to prove? It makes 4 angles, right? 1, 2, 3, 4. So what do we have to prove? The vertically opposite angles, like this. 3 and 1 are equal, and then 2 and 4 are equal. For example, if this is 110, then this will also be 110. And if this is 70, then this will also be 70. So we just have to know any one, and then the rest follows. How is that? Let us see. Look at AB. It is a straight line, which means angle AOB would be 180 degrees. It is a straight line, right? But what is angle AOB? It is the sum of 1 and 2. Now consider COD. Consider CD. It is a straight line. So angle COD would be, again, any straight line makes 180 degrees. But what is this CD? It is 2 plus 3. So there you have both angle 1 plus angle 2 is the same as angle 3 plus angle 2. When is this possible? Only when. Similarly, we can prove that angle 2 is equal to angle 4. So, thus the vertically opposite angles, whenever you see the English alphabet X, this is the vertex, then these two will be equal. This one here and this one here will be equal. Now next, let's go to corresponding angles. Now we prove that the corresponding angles are equal. What are the corresponding angles? We will just take the ones we need. 1, 2, 3, 4. We will first take this. Oh, and what is the corresponding angle? What corresponds to this? The one which comes in the right bottom, it will be 8. 1, 2, 3, 4, 5, 6, 7, 8. So now look at these two. This actually looks like the English alphabet F, right? There a 4 and here a 8. So clearly the way it is inclined, if it is parallel, if these two lines are parallel, then these two angles will be same. But notice that this is clearly true only when it is parallel. It may not be true when it is not parallel. I'll show you an example. See? So clearly you can see the angle here, it is an obtuse angle. This will be the right angle. Above it, it will be an obtuse angle. So it will be somewhere among 130. And look at this angle. This is so small. This will be an acute angle. So this will somewhere be like 30. So it may or may not be equal if it is not parallel. But if the two lines are parallel, then the corresponding angles are equal. It is not just this, every pair. Now consider these two pairs. 1, 2, 3, 4, 5. So its corresponding angle is 5. This just looks like a inverse, as an inverted F. See, 1 comes here and 5 comes here. This looks like an inverted F. Again, the way the two angles are parallel, the two lines are parallel, you can see that the two angles are equal. Again, look at these two. 3, what is its corresponding angle? 7. And what does that look like? That looks like a laterally inverted F, like this. See? So this F, so 3 and 7, that again is equal. The last pair, 2, and what comes on the right top here? 6. That again is equal. So the corresponding angles will be equal if these two lines are parallel, and as I said, it may or may not be equal if it is not parallel. For example, something may look like this. So this will be a different angle, this will be a different angle, and this will be a different angle. But it is always equal when the two lines are parallel. Now we go to the third one, the alternate interior angles. Now we will prove that alternate interior angles are equal. We studied what are the interior angles, 1, 2, 3, 4. There are 4 angles. What are the alternate interior angles? Here. 1, 2, 3, 4, 5, 6. So we are going to prove that 3 and 6 will always be equal. So how will we prove that? Consider 2. How does this look like? Doesn't this look like a vertically opposite angle? There you have a vertex and there you have, doesn't it look like X? So angle 2 will be equal to angle 3. Why is that? Because they are vertically opposite angles. Again, 2 and 6. Why will they be equal? See, that's what we have been learning so far. First we learned the vertically opposite angles will be equal. Next, these two are the corresponding angles. That is the next thing we learned, the corresponding angles. So these will be equal as these are the corresponding angles. So if 2 is equal to 3 and 2 is equal to 6, then angle 3 is naturally equal to angle 6. Similarly, we can prove that angle 4 is equal to angle 5. So the alternate interior angles look like the English alphabet Z. This is 3 and this is 6. So you just have to know the value of any one of this. Suppose this one is 45 degrees. Then this will also be equal to 45 degrees. The same with 4 and 5, but in the laterally inverted form, like this. This is 4 and this is 5. Just know the measure of one of them, the other one will just follow. So these are the 3 pairs of angles which are equal. Now we will go to the pairs of angles which are supplementary. Now the last one, we will see that the interior angles on the same side of the transversal. Here we have the transversal. The same side of transversal will be 1, 2, 3, 4, 6. So these two are supplementary. We are going to prove that 4 plus 6 is 180. And how will we prove that? Look at this angle. Suppose this is angle 2. Look at this. This is a straight angle. Straight angle means its sum is 180 degrees. So that means angle 2 plus angle 4 is 180 degrees. But then What is angle 2 and what is angle 6? How are they related? They are the corresponding angles, and we just now we learned that the corresponding angles are always equal. So 2 is equal to 6, but 2 plus 4 is 180. Therefore 4 plus 6 is equal to 180. It is not just for 4 and 6. The other two interior angles on the other side of the transversal, no? 1, 2, 3 and 5. So this also 3 plus 5 is also equal to 180 degrees. So now we have so far we learnt about so many angles which are equal, and the last one which is supplementary. Now how are we going to use this? We will see. Now see this transversal. Now we will just take one measure. For example, randomly we will pick one. Suppose this one. Suppose this one is 105. Using that information, we will find all the others. Now if this is 105, what is its corresponding place? If for M, this is the right bottom, for L, the right bottom which corresponds to this, the corresponding angle would be same. That is what we proved, right? If the two angles are parallel, the corresponding angles will be equal. So this will also be 105. Now if this is 105, what will this be? We proved that the interior angles on the same side of the transversal will be supplementary. So what will this be? This will be 180 minus 105, and that would be 75 degrees. Now if this is 75 degrees, what about its supplementary? What about its corresponding angle here? Its corresponding angle here will always be 75. If this is 75, what about its vertically opposite one? Again 75. What about this vertically opposite? This will again be 105. If this is 75, its vertically opposite angle will be 75, and this would be 105. So there, with just this one, we started with just this 105, but then we got the answers of all the others. We found what is the measures of all the other angles. Now so far what did we see? We saw that if there are two lines which are parallel and a transversal cuts them, we saw that the corresponding angles are equal, the alternate interior angles are equal, and the interior angles on the same side of the transversal are supplementary. Now it works the other way around also. Suppose you have any two lines L and M. Randomly take an L and take an M, and you don't know if it is parallel or not. Then how will you find if it is parallel? Take a transversal, consider any line which cuts it, then these two lines will be parallel if any of this is true. If the corresponding angles are equal, or if the alternate interior angles are equal, or this is supplementary. Let us see an example. Now consider these two lines L and M. You don't know if they are parallel. You want to find out if they are parallel. You see there is a transversal. It cuts it in 2 points, giving rise to 8 angles. Now see this angle. One is 45 degrees and the other is 70 degrees. So what are these two angles? These two angles are corresponding angles. But you see here, the corresponding angles are not equal. One is 70, other is 45. So that means L is not parallel to M. Let us see one more example. Now again see here two lines L and M. You don't know if they are parallel, and you see the angles that a transversal has made. One is 110, the other is 111. So now actually you don't see any corresponding angles or any alternate interior angles. So first you have to find few more angles, right? If this is 110, then what will this be? This will be its vertically opposite angles. So this will also be equal to 110. So if this is 110 and this is 111, then what do we have? We have interior angles on the same side of the transversal. And is it supplementary? You add these two, do you get 180? No. So that means this L is also not parallel to M. Now we will see the last example. Look at these lines L and M. We want to see if they are parallel. See, a transversal cuts them in such a way that this angle and this angle is 90. That means the corresponding angles are equal. This condition is satisfied. So that means this L is parallel to M. That is all. With this we come to the end of this topic. Inshallah, till we meet again, stay safe.